Good morning, everybody. Welcome back to class. Today we're going to start chapter 10, and I know it's a little weird you're saying, wait, we're starting chapter 10 and 10.2? Yeah. We're going to start with 10.2 today because in 10.1, believe it or not, we need some skills that we don't have yet. So I wanted to show you those skills first, and then we'll go back to 10.1, and I'll show you how to work what's called the Pythagorean theorem. Today, guys, we're gonna learn how to simplify radicals. This is very important. Not only is it important, of course, for this class and this test and these quizzes, etc., but this is going to be something that is going to be following you through geometry, algebra 2, and beyond. So if you learn it now, when you go ahead and learn it again in geometry, or rather, you're not going to have a section like this in geometry. You're going to have a section where you need to know how to simplify radicals. They're not going to teach it to you ever again. So this is the one time you have to learn this. So I'm going to hopefully really explain this to you well so that you can really perform well in the future. Today we're going to learn how to simplify radicals. Before we move forward, let's go back in time just a little bit. We're going to be working with square roots today, guys. And I need you to understand the concept of what square roots are, okay? When you're talking about a square root, that's this symbol right here. A square root is basically asking you, for example, this. When they say, what is the square root of 4? They're asking, okay, all of you are saying 2. Yes, but can anyone explain to me why it's 2? Yeah, I like that. That's good. Basically what's happening here, guys, is when you have a square root, the question that it's asking is, what number times itself equals this inside value? That's the question. What number times itself equals the inside value? What number times itself equals the inside value? That's what square root means. That's what they're asking you, okay? You're not always going to have a perfect square. Sometimes you have to simplify them, and those are the skills we're going to learn today. But just as a little review, 5 squared is 25. So if I say, what's the square root of 25? Well, 5 times 5 is 25. The number that multiplied to itself was 5. Okay? It's 5, because there's 2 5s. 6 squared is 36. So therefore, the square root of 36 is 6. 12 squared is 144. So therefore, the square root of 144 is 12. So when we're dealing with square roots, you have to refer back to, okay, what number times itself gives me the inside value? Okay, that's the main concept of this. Does that make sense so far, gentlemen? Okay, so square roots, my friends, have 2 real roots. There's a plus or minus square root. The positive root, known as the principal root, or the principal nth root, and its symbol is just square root of n. When they just give you a square root of n, they're looking for the positive root. Okay? So the square root, for example, if I just go like this, square root of 25, they're looking for the positive root, which is just 5. If I say, I want the negative root, okay? The negative root, or its opposite, is negative square root of n. So if I say, what's the negative square root of 25? That's going to be negative 5. Let me explain why you have a plus or minus root for square roots. What is 5 times 5? What is negative 5 times negative 5? Okay. So when they say to you, what is the square root plus or minus of 25, they want both the positive roots and the negative roots. So square root of 25 really officially is plus or minus 5. Because 5 times 5 equals 25, and negative 5 times negative 5 also equals 25. So if I just write it like this, I'm looking for the positive root and only the positive root. If they ask you like this, I'm looking for the negative root and only the negative root. And if I ask you like this, I'm asking for both the positive root and the negative root. Is everyone with me so far? Okay. As far as the radical signs, or the square root signs, let me explain how this works. You have this nth radical sign and you have an a in there. Let's explain what this means. This little n here, this number right here, that's called the index. When you don't have a number there, it is 2. So this is a square root. If I have a 3 here, that means a cubed root. If I have a 4 here, that means a fourth root. This n is going to tell you the root that you're looking for. We, right now in this class, are just going to work with square roots. Okay? Just with square roots. But I need you to know that this number can change. The index can change. Now, what is the difference there? Let me give you an example. I have the square root of 4. That equals 2. But if I say the cube root of 8, think about it's 2 as well, but let me explain why. Thank you. Listen, didn't I say that the square root is what number times itself equals the inside? Well, in this case, if you break this down, gentlemen, you've got a 2 times 2. Do you see how you have 2 2's here, guys? Remember that I told you if there's no index, it's really an invisible 2, correct? Now hear me out. The index tells you the number of values that you need to pull 1 out. Let me explain. If this is a 2, how many 2's do I have here? So I have 1, 2 2's, so it comes out as 1 of that value. For a cube root, they're asking you, what number times itself 3 times equals this inside number? Well, if you break this down, this is going to be 4 times 2, and the 4 breaks down to 2 times 2. Now, check it out, guys. I have a cubed root, right? So what that's telling me, or the reader, is, hey, reader, every set of 3 of the same numbers comes out as 1 value. So I have a 2 and a 2 and a 2, and it comes out as a 2. If I have a fifth root, it's going to basically be asking you, what number times itself 5 times gives you the inside number? You guys with me so far? You promise? Okay. So now, let's get back to this radical. Okay, so the index is going to tell you again, how many values do I need to pull 1 of those out? How many values do I need to pull 1 of those out? When I don't have an index, it is a square root. There's an invisible 2. That's the index. The actual symbol here, that's called the radical sign. It's called a radical. It's not called a square root. This is a square root because there's an invisible 2. But like I said, this is a cubed root, etc., etc., etc. The actual symbol itself is called a radical. What gives it the name square root or cube root or fourth root, what gives it that name is the index. Okay? Excuse me. And the inside value inside of the radical is called the radicand. The radicand. Okay? So that radical symbol, remember, that is not called a square root. It's called a radical sign. If there's no index, then it's a square root. If the index is 3, it's a cube root. If the index is 4, it's a fourth root. If the index is 5, it's a fifth root, etc., etc. But the symbol itself is called a radical sign. The inside numbers are radicand, and the root is called the index. You guys with me so far? Okay. Now, like I had just finished saying, if there is no index, then it is a square root. The index equals 2 when it's blank. It's an invisible 2. Yes, sir?
So what number can the index go?
The index can go to whatever it wants, literally. Now, what do we normally work with in math? They usually go to 4, 5, or 6 sometimes, but it could technically go as high as you want it to. Okay? Thank you for asking, son. Now, a simplified radical. When we simplify a radical, gentlemen, okay, we're going to have a simplified radicand. What that means is we cannot break it down any further. We cannot pull out any other square roots. It's simplified. If the index is even, pay attention to this, if it's a 2, a 4, a 6, 8, a 10, if the index is even, the radicand must be positive. Let me explain why. Guys, let's look at the square root of -4. What times itself equals -4? Really? 2 times 2 equals 4, not -4. No, -2 times -2 equals +4, not -4. -2 times 2, that's not the same number. It has to be the same exact number, guys. 2 times 2 equals 4. That does not work. -2 times -2 equals 4. That does not work. There is no such thing as a negative square root. What this is going to equal is 2i. We don't have to know that right now. This is Algebra 2. But I just want to show you what that equals is 2i. I being an imaginary number. That doesn't exist in the real number system. There is no way to get a negative square root when the radicand is negative. It is impossible in the real number system. This is an imaginary number. It does not exist. Okay? So if it's an even root, the radicand better be positive. Now, if the index is odd, then whatever. It can be a negative radicand or a positive. For example, the cube root of -8. This is going to break up. Check it out. The negative breaks up into a, this doesn't really matter when it's cubed. Because -8 is made up of -2 times -2 times -2. -2 times -2 is 4. 4 times -2 is -8. Bingo. I have 1, 2, 3 -2's. I have an index of 3, so 1, 2, 3 comes out as one value of -2. That only works with odd indexes. 3, 5, 7, 9, etc., etc., etc. So don't with me so far. Bless you. Okay. Next. Simplified radical must not have any fractions in the radicand. Cannot have any fractions in the radicand. And a simplified radical must have no radicals in the denominator. You can never have a number like this. It's not going to work. There's something we're going to do today to simplify this. But if you're left like this on a quiz or a test, it's going to be marked wrong. You're not done yet. This is not considered a simplified radical. You guys with me so far? Okay, let's continue. Now, before we can simplify, we got to know where the simplification comes from. And we're going to have to learn the multiplication property of square roots. If the nth root of a times the nth root of b are real numbers, then the nth root of a times the nth root of b is the nth root of ab. What am I talking about? As long as the radical has the same root, you can multiply the radicands of the radicals. For example, square root of 5 times square root of 2 is the square root of 10. Done. Cube root of 6 times cube root of 3 is the cube root of 18. But if I say the square root of 5 times the cube root of 6, that cannot be done. It's not, you can't. No answer. Okay? They have to have the same root, or index rather. Yes, sir.
Instead of the square root of 5 times the square root of 2, x.
Okay, the question was, if I have the square root of 5 times the square root of 2x, you have the same index, so you multiply the radicands. So that'd be 10x, square root of 10x. Thank you, son. Okay? If I have a number outside of it, like 3 square root of 3 times 5 square root of 8, this is going to become 3 times 5 is 15, that's the whole number, times the square root of 24. And again, we're going to be able to simplify all of these, but we got to walk before we run. So does that make sense so far? As long as the index is the same, you keep the index and you can multiply the inside radicands. So, look what it says in red there. In order to multiply radical expressions, they must have the same index. If they do not have the same index, guys, I'm sorry, you're out of luck. Now, let's go ahead and practice just a little bit. Okay? We're at this point not simplifying. We are not simplifying yet. I'm just showing you how to multiply them together. We are not simplifying yet. Square root of 5 times square root of 2, do they have the same index? So square root of 10, done. Square root of 11 times square root of 2, do they have the same index? Yes, so square root of 22. Square root of 14 times square root of 3, do they have the same index? Yes, that's square root of 42. Square root of 5 times square root of 7, do they have the same index? Yes, so that's square root of 35. Square root of 5x squared y to the 4th times square root of 6x to the 4th y cubed. Do they have the same index? So this is going to be the square root of 30 x to the 6th y to the 7th. Excellent. And square root of 3xy cubed times square root of 7x cubed y squared. Square root of 21x to the 4th y to the 5th. Fantastic. Great job. Does that make sense, my brothers? Okay, awesome. That's how you multiply radicals. Just for giggles, what would the cube root of 5x times the square root of 7x be? No answer. Good job, guys. It's just going to stay like that. You can't do it. Okay? Yes, sir. I'm sorry,
No, not the index. In front of the index.
in front, here?
Yeah.
Yeah, there's always a 1 in front of everything. Yeah, because 1 times anything is itself, sir. But here it's not a 1. When it's invisible, it's 2, my brothers. Thank you, sir. May I continue? Yes, sir. Sure. What's the square root of 1? 1. No, the index, no, because if the index was a 1, then it would just be itself. Think about that. What's the 1 root of 2? 2, it doesn't make sense. Yeah. No. But thank you for asking. Yeah, the index is never 1, sir. Yes, sir.
Are we not following that? If there's no answer, we just leave it to
Yeah, just put no answer, or you're not possible. You can't do it. Thank you, sir. May I continue? Great questions. Thank you. Okay, now let's simplify. Simplifying square root radicals is very easy if, big if you know your perfect squares. Remember that a perfect square is a product that came from multiplying a number or variable times itself. For example, the square root of 25 is 5, since 5 squared equals 25. 25 breaks down into 5 times 5. I have a square root, so that means I need 2 of the same value to pull 1 out. You feel me? I have 1, 2 5s, so I pull out 1 5. You guys with me, guys? Okay. I put for you guys the first 15 perfect squares. You want to memorize them. You really do. Because this is going to help you recognize perfect squares in larger numbers. And it's going to really help you understand how to simplify quickly, efficiently, and without any stress to you. Now, if you don't want to memorize these, I can do nothing for you. I cannot help you at that point. You have to memorize the perfect squares. Have to. There's no choice, unfortunately, gentlemen. This is the way of the world. So I'm not going to read them to you. You can read. They're right there. Memorize them. Yes, sir. Square root of 7, there is no perfect square for that. Square root of 7 cannot break down. This breaks down into 7 times 1. Do I have a pair of numbers that I can pull out? So square root of 7 equals square root of 7, and that's it. I cannot simplify that any further, sir. Thank you, my brother. Sir. Okay. So these are the perfect squares. Recognizing perfect squares makes simplifying square roots easy and fun, believe it or not, because it's kind of like a puzzle. Sometimes, guys, you have to simplify variables in the radicands, which is also very easy. If you remember the following, all you have to do is divide the exponent of the variable inside of the radicand by the index of the given radical. The whole number comes out of the radicand, and the remainder stay inside the radicand. What is this man talking about? Let's say I have the square root of 11. You with me here? Following these rules, what's the exponent of the radicand? What's the exponent of the radicand? 11. This is the radicand, guys. Please, we've just gone over this and you just said you understood it. Please. The radicand is the inside. So again, what is the exponent of the radicand? Okay, what is the index of this radical? So divide the exponent by the index. 2 goes into 11 5 times, right? And isn't there a remainder of 1? So this is going to equal x to the 5th, because it went in 5 even times. And how many do I have left over? 1x. Do you guys see that?
Yes.
What if I had the square root of x to the 30th? Okay, what's 30 divided by 2? So it comes out x to the 15th. Do I have any leftovers? No. What if I have square root of x to the 7th? What's 7 divided by 2? And remainder? So this is going to be x cubed with a remainder of 1x inside. Now, let me show you why this trick works. If I break down x to the 7th, 6, 7. Isn't it x times x times x times x times x times x times x? You with me? Didn't I say that the index tells you how many of one value you need to pull out 1 to the outside? Check it out. I have an x and an x, so I pull out an x. You with me? I have an x and an x, so I pull out another x. I have an x and an x, so I pull out another x, and hey, I have 1 x left over. X times x times x is x cubed, and I have 1 x left over. You can do it the long way if you want, but it's going to take a lot of time. It's a lot easier to simply divide the radicand's exponent by the index. The number of whole times that it goes in comes outside of the radical. The remainder stays inside the radicand. That makes sense, guys? You sure? Okay. Let's continue then. Let's practice, huh? Square root of 125. Okay. There is no perfect square for 125, guys, so we're going to have to learn how to break things down. 25 breaks down into 5 times 25. 25 breaks down into 5 times 5. Circle all of the prime numbers because that tells you I cannot go any further. Are you with me so far? Okay, so check it out, guys. It's a square root. So I need how many values to pull one out? 2. So I have a 5 and a 5, which comes out as a 5. And I have 1 5 left over. Are you with me so far? N. Okay. Does n to the 1, does 2 go into 1 at all? So n stays inside. Done. Done. 216. 216 breaks up into 2 times 108. 108 breaks up into 2 times 54. 50. Hold on, let me give myself some more room. So I have 2 times 108. 2 times 54. 2 times 27. 3 times 9. And 3 times 3. You guys with me so far on how I broke that down? Notice how I circled all the primes. Yeah? Okay. So I have a 2 and a 2, so that comes out as a 2. I have a 3 and a 3, that comes out as a 3. Can I take out a v?
Interruption will appear. Resume. Please come.
Can I take out a v, guys? Do I have 2 v's to take out? No. Now, what do I have left over inside the radicand? A 2 and a 3 and a v. So a 2 and a 3 and a v. So my answer here is 6 square root of 6v. You guys with me? Yes, sir. Correct. You multiply what's out here and you multiply what's inside the radicand, sir. Thank you. Okay. 512k squared. 512 is 2 times 256. 256 is 2 times 128. 128 is 2 times 64. Now, remember how I told you perfect squares? What's the square root of 64? Okay, so I can pull out an 8 immediately, right? Bye-bye. I have a 2 and a 2, so that comes out as another 2. What's the square root of k squared? Pull out a k, and I have left over. What's my leftover here? There's 2 right here, which I have not been able to get out. So this is going to equal 16k to the square root of 2. You guys with me? Yes? Okay. 512m to the third. Well, it's going to break out the same way. 2 times 256. 2 times 128. 2 times 64. Now, if you didn't know that 64 was a perfect square, you could keep going and keep breaking it down. But isn't it a lot easier and doesn't it save you a lot of time once you say, hey, wait a second, I've got a perfect square right there. So this is going to, again, be 8, because the square root of 64 is 8. I have a 2 and a 2, so that comes out as a 2. Now, m cubed, what's 3 divided by 2? How many times does it go in evenly? 1 time. And what do I have left over? Hold on, let me move this over. Oh, my Lord. Oh, my Lord. Hold on. Hold on. Oh, boy. Okay, that ain't going to work. So why don't I just do this? An 8 times a 2 times an m, and I have a radical. What's my leftover? A 2 and an m. So this is going to equal 16m times the square root of 2m. Are you guys with me? Okay. Square root of 216. 216 breaks up into 2 times 108. 108 breaks up into 2 times 54. 54 breaks up into 6 times 9, right? Hey, wait a second. What do we know about 9 here? Yeah. Square root of 9 is 3. Then I have a 2 and a 2, and that comes out as a 2. This 6 breaks down into a 2 and a 3. So I have my 3 from the square root of 9. A 2 and a 2 comes out as a 2. What's the square root of k to the 4th? K squared, because 4 divided by 2 is 2. There's nothing left over. And I have a square root of leftover of 2 times 3, which is 6. So this is going to be 6k squared times the square root of 6. Does that make sense? Okay. 100v cubed. This is an easy one. What's the square root of 100? 10. What's the square root of v cubed? Yes. 3 divided by 2. 2 goes into 3 one whole time. And there's 1 v left over. Does that make sense? 80p cubed. This is 2 times 40, which is 2 times 20, which is 4 times 5. Hey, wait a second. 4 is a perfect square, isn't it? Square root of 4 is 2. Then I have a 2 and a 2, so that comes out as another 2. What's the square root of p cubed? 1p comes out, and I'm going to have left over inside of the radical 5p. So this equals 4p square root of 5p. Does that make sense, guys? Promise? Okay. Square root of 45p squared. 45 breaks up into 9 times 5. This should be an indicator. What's the square root of 9? 3. What's the square root of p squared? P. And what do I have left over? 5. You guys getting the hang of this? Okay. 147 excuse me. Square root of 147 m cubed n cubed. Okay, well, 147 is going to break up into, I can't divide it by 2, but if I go 1 plus 4 plus 7, that's going to be 12. So I can't divide it by 3. 3 goes into this 49 times. Hey, wait a second. What's the square root of 49? Bam. 7. What's the square root of m cubed? I have an m, and I have one m inside, right? What's the square root of n cubed? N, and one n inside. And do I have any leftover numbers in the radicand? A 3. So this is going to equal 7mn times the square root of 3mn. Does that make sense? 200 m to the 4th n. 200 breaks up into 2 times 100. Hey, hold your horses. What's the square root of 100, man? So that goes bye-bye. That's 10. What do I have left over in the square root? A 2. What's the square root of m to the 4th? M squared. Can I take out an n? I only have one n in the square root. I need 2 n's to pull it out, so no, that stays inside. You guys with me? Okay. 70, square root of 75x squared y. 75 is 3 times 25. Hold your horses. What's the square root of 25? 5. What's the number that's going to be left over in the radical? A 3. What's the square root of x squared? X. Can I pull out a y from a square root? Done. Last but not least, what's the square root of 64? 8. What's the square root of m cubed? M and one m inside. What's the square root of n cubed? N and then 1 on the inside. Does that make sense, gentlemen? Okay. This is what we're going to do, guys, because I know that time is running out, and I still have 2 full pages to teach you, and one of them is teaching you how to divide radicals, and you know what? I think we're going to call it right here. I think we're actually just going to do part 1 today. It took me a little bit longer than I had anticipated because I wanted to do a thorough job. So, you know what? That's exactly what we're going to do. We're going to leave part 2 of 10.2 for Monday. Okay? You have all the notes already on your PDF, but we're going to leave 10.2 for Monday. 10.2 part 1 homework is valid. So when you see it on Edline, you're going to see 10.2 part 1. I want you to do the homework that's on from page 634 to 635. Okay? 634 to 635. That's the homework. Just 10.2 part 1. Okay? You had a question, my brother? Yeah, when we come to this page, to page 5, this is part 2. And we will do this on Monday. Okay? Let me close this down, and with the few minutes I have left, we'll practice some on the board. Thank you very much. God bless you, and have a great day.